We will be having session today on 12-factor apps. 12 factors are the steps which you need to follow to build any microservices, and we'll go through that. The core objective of 12-factor apps is the application should be serverless, it should be portable, it should be in a state where you can do continuous deployment on top of that, it should be scalable, and it should be able to easily deploy on modern cloud platform. So there are 12, which these are the 12 factor apps. First is code base, second is dependencies, third is config, fourth is backend services, fifth is build, release and run, sixth is processes, seventh is port binding, eighth is concurrency, ninth is disposability, 10th is dev prod party, 11th is log, and 12th is admin processes. Let's go to the first one, code base. What it says in code base that we should have one code base track in revise, control and many deployment. That means we should always have a version control for each project, and it should be made in such a way that only making configuration changes we can deploy the same code to dev, to stage, to production. Okay, now get to the next point, dependencies. What he says is dependencies should be explicitly declared and isolated dependencies. What exactly it says that if you have any dependencies in your application, it should be declared with version explicitly in a proper manner. Okay, in case of Python, we have requirement.txt. Similarly, whatever are your dependencies you define. Second is if you have dependency on your database, or you're using messaging queue, or you're using Redis for your project purpose, it should be isolated and there should be a configuration details by which you can do it, and it should be developed in such a way that, for example, today you are using Redis and you want to shift to Memcache, it should be easily doable out there. So whatever is the configuration detail, when you are building the application, you should do the required change at the same time. Config any informations which would change, okay, or which is outside of your process or applications, it should be done in configurations. Similarly, if you are having you have an activity where you have to store informations, you should put it into backend. However, there are two parts when you talk about configuration, so we will cover backend service in the further points. But if you have any configuration changes, just like if you have connection string for database, you have any third-party API which you have to configure, you should not write in the code. It should be put in the config file. Now comes the backend services. Backend service should be treated as an attached resources. What exactly it means that in your computer, when we boot or we can add a volume, the volume can be a local volume, okay, or disk or a hard drive in your local machine, or it will be a network file share. So we can mount so easily and does not change the behavior. Same when we're building the services, we should have the same mindset when you're doing that. We should not, for example, basic example is SMTP service. When we are using SMTP service on local or within the premises, if you are using Microsoft Exchange, people use anonymous access, but when it is goes to external, they have a valid username passwords to do that. So same process should be done when you are building a backend services. If you are either it's a local or it's a third-party application, it should build in a way that it can be worked. If you change the configuration, it should be able to work out there. Okay. So these are the 2 points which we have covered out there. Next is build, release and run. Whatever applications you build, okay, for example, if you are building any application, if it's a website, okay, so first step will be you will build that applications. Second will be when you release that. So when it goes for release, it should have, for example, if you're deploying in the web version or if you're deploying in the dev version, it should have all the configuration ready, so it should be ready. And when you deploy, it should run. For example, if you're building a container image, it should run in the container image, and in this case, okay, your release file will be the image artifacts. So that's what it's trying to say: build, release, and run. Strictly separate build and run stages. So each environment, where if you are building the same code in build, but when it goes to the release mode with the configuration detail, it should be ready for staging or production deployment at the same time. And when it is deployed in production, it should have the relevant configurations out there. Processes. Each process should be built in such a way that it should not be it should not store information. For example, very simple example is that whenever user login, you display the user's first name and last name out there. So it should not be stored that information inside of applications. When the process comes, you should have a or you should have a cache where you know that this is the detail of the user, or you get an ID and you fetch that detail from the memcache and display the user information out there. So it should not be part or be associated with the processes. The only reason is that if for some reason the specific application get hang and the request goes to some other process, it should be able to work without any dependency out there. Okay, if you are getting the information, then it becomes the case of sticky sessions. What is sticky session is that once you store a session details in the processes, it should only get the response directly from the load balancer, and which is not advisable when you're building a 12-factor app. Every service should be explicitly exposing that service via port. Okay, so port service, for example, even if you have a database, if you are deploying in 12-factor apps, it will have its port number where you can connect and gather the information or store the information out there. Similarly, if it's a website, you will have a port, for example, 808080, by which you can the service will listen the request, whatever information you ask for it, it will provide you and give the response back to you. Concurrency is that whichever application you build, you should scale out via process model. In this example, it says that if it is a web application, it should be built in a way that you can have multiple instances at the same time, you can run concurrently at the same time. Similarly, if it is a database which is having a storage in a location where it stores the data out there, it should be built in such a way that it can be. Similarly, if it's a batch process, you should build in such a way that it can be concurrently expanded and multiple activities can be done at the same time. Disposability. So whenever you're building the application, you should build the application in such a mindset that it can be disposed in few seconds. For example, if it having any request in its hand, it should process. Once the specific request is done, it should kill itself. Okay, it should not that if you stop that some specific services, the complete activity should stop. Okay, the reason is the concurrency, which we just discussed before that. Dev prod priority. What normally happens previously used to happen was that developer used to build a system on his local machine where it only, for example, it is working on front end, it only have the modules of front end, it does not know the complete application modules. So even when he do the development, it should be working on his front end part, but when this specific module deployed in the dev environment, it should function completely, so that the proper CI/CD process or unit system testing or complete automation testing can be done out there. So what you can do when it says about dev prod priority is that for a dev environment, because there are not lots of requests, you can compromise on infrastructure, you can have a low end infrastructure out there, but the environment should remain the same. For example, if the request comes to load balancer, load balancers connect to the front end connect to the load balancer, that load balancer connects to the database, and database give the response back. So this same behavior should remain the same. But if in production you have 9 or 10 instances of your specific application or front end, but here you can go with 2 or 1 instance. So you can reduce or increase based on the request, but the complete architecture should remain the same. Logging should not happen within that same process. It should be a event stream. For example, whenever any log happen, whenever you start an activity, you log it. When it's done, it should say its complete activity, and it should not store in that process. It should store as external service, or it should be a stream. So it there for like Fluent or any other log metrics server can take that log and put into a centralized systems for that system to know what is the performance of the applications, which activities is completed and which are failed out there. Last part is admin processes. In case of admin processes, for example, if you are having a batch which take a database migrations of your system, so it should not be part of the process. There should be a separate admin process to do this activity. Similarly, if you have certain configuration details which need to be reset, if you need such a certain module, you should build a separate process for that. You should not inject a working process with the admin process. Or for example, if you have a website where which take the request and do the processing on top of that, or making call to the third-party application, you should not do that. Thank you for listening about 12 factor apps, and hope you like